different types of transformations on the left, and then different parent functions that we'll be using on the right. So looking at the first one in the purple box, horizontal shift, we had this one yesterday. This is when you had a number that was added or subtracted inside those absolute value bars. Today, it's just a parenthesis. And remember that anytime it's inside, it kind of works opposite from what your brain wants you to think. If you see x minus a number inside, that actually means it moves your graph to the right. And if you see x plus some sort of number, that means it takes your graph and moves it to the left. That was the h value from yesterday. And then underneath that, we've got our vertical shift. We had this one yesterday too. This is when the number was added outside the absolute value bars. And when it's outside, it's very straightforward. If you see plus a number, it's going to move it up. If you see minus a number, it's going to move it down. And then we only had one type of reflection yesterday. Yesterday we had this type of reflection where the negative was in front of the function, and that is a reflection over the x-axis. But if that negative is inside the parentheses, you can also reflect it over the y-axis. Sometimes when you reflect something over the y-axis, though, it doesn't look a whole lot different, which is what you see here. It looks the same. Y-axis. And then yesterday we also had vertical stretch and compressions when the number was in front of the function. Same thing here, if it's in front of the function, in front of the function. If that number is greater than 1, that was called a vertical stretch, which is like 2, 3, 4, stuff like that. But if that number was between 0 and 1, some sort of fraction or decimal, we call that a vertical compression. It's going to take it and flatten it out. And then we also have horizontal stretches or compressions, which are brand new for today. That's when you have a number that's multiplied inside the parentheses. If that number is greater than 1, that's going to be a horizontal compression. Horizontal compression, meaning it's going to literally compress it from the sides, compress it horizontally. If that number is between 0 and 1, that's going to be a horizontal stretch, meaning it's going to take it and literally stretch it horizontally. If it's a U-shaped graph, it grabs it, pulls it out horizontally. And then our three types of functions that we're working with today, we've got the linear parent function. Linear parent function, remember, is just y equals x. So all of the x's that you pick should be equal to whatever y's. The x and the y should be the same. X equals y, x equals y. We've got the quadratic parent function, which is y equals x squared. So that means any x that you pick, its corresponding y value will just be the square of that number. This shape, remember, is called a parabola, directly from Algebra 1. And then we have cubic parent function, brand new, but it's similar to quadratic. You just have to cube the number that you plug in. So any x value that you pick, the y value will be that number to the third power. So that's what all of these y's are on the right, the numbers to the third power. And you don't have to like memorize these. It's pretty easy to know. Like the first one, y equals x. The second one, y equals square of the x. The last one, y equals to the third power of the x. So you're not having to memorize a table. You just need to know how the exponent works.
Why is it like the opposite?
Oh, I'll show you that in just a second. I'll write that down here. Okay, the general shape or the general form that you're going to see these transformations in, you're going to have some sort of a value out front, f of bx minus h, and then we'll have plus k out here. We saw h and k yesterday. We saw a yesterday. B is really the only thing that's kind of brand new. Anything that's inside the parentheses, that's this. So the b and the h, these are going to affect your x values of your table, but it affects it inversely from what you see. Okay, so affects the x values, but inversely. Affects x values of your table inversely. So that's kind of like if you see minus 3, that means you're going to add 3 to your x's. If you see divided by 3, that means you're going to multiply 3 to your x's. Whatever the x's are, it's going to do the opposite of that to your table. And then the two that are not in the parentheses, that would be this a value out here and this k value out here. Not in the parentheses affects the y values of your table exactly as it's shown. Affects the y values exactly as it's shown, which means like directly as it's shown. Affects, that says effectly, that is not a word. Affects y values directly. And we kind of got a sneak peek at that yesterday when we were talking about the h of the vertex. We always had to write down the opposite for this one. This one is also going to affect the y values directly. All right, let's try one on the back. Everybody ready to try? So we're going to be given some sort of parent function. We're going to identify what transformations are happening to that parent function, and then we're going to adjust the point values and graph it. So looking at the parent function that we're given, it's the quadratic parent function, f of x equals x squared. Okay, I'm going to use two different highlighter colors for what affects x's and what affects y's. I have the 1/2 x inside the parentheses. That's going to be one that affects my x values. And then I have the -5 that's not in the parentheses. That'll affect my y values. So this one only has two transformations that I need to write down. The 1/2 x, that's inside the parentheses. Let's go flip back to our table for what that does. It's a 1/2 inside the parentheses. That's going to be either a horizontal, stretch, or compress. Is that number greater than 1, or is it between 0 and 1? Between. So that's what's called a horizontal stretch. Horizontal stretch. Okay, the last one, we had this yesterday. That was a k value. What does a k value of -5 do? You can flip to the front if you need to. Shift it down. Down 5. Very good. Okay, and then I'm going to start by just writing my parent function table. Again, you don't have to like flip back and forth and be like, what is it again? What is it again? I'm going to start by just writing x values, some negatives, 0, and a positive. -3, -2, -1, 0, 1, 2, and 3. And then to find the corresponding y values, you just need to square the x values. X squared. What's -3 squared? 9. And then we'll have 4, and then 1. 0 squared is still 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So this is our parent function table. Okay, so again, whatever's inside the parentheses is going to affect the x values inversely from what you see. Okay, so if I see times 1/2, anyone know what it's actually going to do? It's going to multiply by 2. It's going to do the opposite. If you struggle with that, let me show you how I do it, especially when it's like a 2 or 3 step in here. Here's what I usually do is I take what's inside the parentheses and I set it equal to a number sign, hashtag for you youngins, and then I solve this for x. My one step to solve for x would be to multiply by 2. Multiply by 2. So this kind of helps me visualize, oh, I need to take those x's and do 2 times those numbers. So I'm going to go down the x column, times 2, times 2, inversely from this 1/2 right here. So times 2 to all my x's. Okay, the y value though, anything not inside the parentheses, which for us is just the -5, that's going to affect y values directly as what you see. If you see -5, we're going to -5 to our y values. So I'm going to go down the y column and just subtract 5 from each of those. -5. And then I'm going to write out my new table with my new points. These should be the transformed points of like where it is now after the 2 transformations. So just doing the calculations that I have on the first table. All the x's we're going to multiply by 2. That would be -6, -4, -2, 0 still, 2, 4, and 6. And then for the y's, each of those, remember, we're just subtracting 5. So I'll have 4. 4 minus 5 is -1. 1 minus 5 is -4. 0 minus 5 is -5. And then another -4, and then another -1. And then 9 minus 5 would be +4. So these new points in this table, this is what we're going to plot. This should be the transformed function. Plot these guys. Let's do it. All right, -6, +4. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. negative 4, negative 1, negative 2, negative 4, 0, negative 5, positive 2, negative 4. The hardest part on this whole question, I think, is just counting the lines in the table. 4, negative 1, 6, 1, 2, 3, 4, 6, 4. And that is it. Connect the dots. It should be a U-shaped graph. It shouldn't have a sharp point at the bottom, because what type of function does have a sharp point at the bottom? Absolute value. That's what we did yesterday. So make sure it has a little curve to it on the bottom. I have to turn my paper when I do this. I can't draw it straight on. I don't know why. My brain does not like doing that. Ta-da! We did a transformation. How's y'all's graph look? Looks good? Looks good? Yeah, as it should. Alright, second one. What type of function are we starting with? That is the linear parent function, where the x value equals the y value. Again, using my two highlighter colors to differentiate what affects the x. That's going to be what's inside the parentheses. And then what affects the y's is going to be outside the parentheses. And there's two of those. There's one in the front and one in the back. So when I write down my transformations, I should be writing down 3. There's 3 of them on this one. One for each of those numbers for how it affects the graph. Let's start with the 2 out front. The 2 that's being multiplied by the function. 2 that's being multiplied by the function. That's some sort of vertical stretch or compress. Which one would it be? Stretch? It's a stretch. Vertical stretch. Okay. The plus 4, this was an H. We had those yesterday. What would a plus 4 do inside the parentheses? Lefts. Left 4. And then the minus 2, not in parentheses, would be down 2. That was like K. We had those yesterday. Okay. Again, I'm going to start with the parent linear function, which, remember, you don't have to like memorize the tables. Just memorize how to create one. Whatever x's you pick, those should be your y's, because the x equals the y on this one. I'm just going to go boring and do my 3 negatives, 0, and then my 3 positives. And then what should be those y values?
Same thing.
The same thing, because the x equals the y. Alright, remember, anything inside the parentheses is going to affect the x values inversely from what you see. So if we see plus 4 to our x's, what are we going to do? Minus 4 to our x's. And again, if you struggle with thinking about what the inverse would be, I always take what's inside the parentheses, set it equal to a number sign, solve this little baby equation, and that will help me think like, oh, I just need to take my numbers and minus 4. Take your numbers and minus 4. Got it? And then there's 2 y transformations. There's a times 2 up front, that's times, and a minus 2 out back. If you're doing order of operations, what should you do first? Multiply. So we gotta multiply by 2, then subtract 2. I'm gonna go through and write my multiply by 2 on them. I wish I had a skinnier pen. Multiply by 2, subtract 2. And I'll make my new table. Okay, so remember, for the x's, we're just subtracting 4. Negative 3 minus 4 is negative 7. Then negative 6. Then negative 5. Then negative 4. Alright, all the way down. Good. And then our y's, remember, we're multiplying first. So we're going to multiply by 2, then subtract 2 for those y's. 2 times negative 3 would be negative 6. And then when I subtract 2, I get negative 8. 2 times negative 2, that's negative 4. And then when you subtract 2, you get negative 6. Okay, what's the next one going to be? Negative 2. And then when we subtract 2, we'll get negative 4. Very good. Okay. Yeah, he was ahead of us. 2 times 0 minus 2. What's 2 times 0 minus 2? Negative 2. Okay, 2 times 1 minus 2? That one's 0. 2 times 2 minus 2? 2. And then 2 times 3 minus 2? 4. Alright, what are we doing with these new points? Graph them. That should be my new transformed function. That's a vertical stretch and left 4 and down 2 from the original. Let's see. Negatives. I'm telling you, the hardest part of this is literally just counting these tiny lines. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. Negative 5. Ta-da! There we go. All right. Now I know you're saying, like, how is this vertically stretched? It does not look a whole lot different when you vertically stretch a straight line. It literally just means you're pulling on it vertically, so it's going to look a little steeper than the original. That's really about it. Whereas a vertical compress would look a little flatter than the original. How's y'all's graph look? Looks good. All right. What type of function do we have on the third one? Cubic function. Good. F of x equals x to the third power. So whatever you plug in for x, you'll just raise it to the third power to find the y. Inside the parentheses, we have an x minus 3. Outside the parentheses, we have a negative 1/2 and a plus 2. Okay, this one, I know there's only 3 numbers, but there are 4 transformations. I'm going to test you and your group to identify 4 of them. All right, group. I'll give you about 2 minutes to see if you can find all 4 of what those transformations would be. Feel free to flip back to the front if needed to refer back to your table. I'm going to take attendance while y'all do that.
Horizontal is inside of the parentheses. So that's applying to the x. When vertical is applying to the not in this one. But it's not in this one. Vertically. Right.
All right, I'm just going to popcorn around, get some answers from different groups. Julia, what's one y'all found? Yes, it is a reflection over the x-axis. Technically, it's just the negative that causes the reflection over the x-axis. Reflects over x. All right, Harvey, what's another one y'all found? Not a vertical stretch. The 1/2 would not be a vertical stretch. If we look back at our table, that would be a vertical compression. That's between 0 and 1, so that would be a compression. Vertical compression. All right, Sean, what's another one y'all found? A vertical shift, which direction?
Up.
Up, yep, that would be up 2. Very good. 2. Alright, let's see. Nico, which one y'all got? The last one. Right 3. The x minus 3 would be right 3. Very good. Alright, and I saw a lot of people working ahead when it went ahead and make their table. Excellent. Again, when you're making your table, to find the y's, you just need to the third power, whatever you wrote for your x's. -3, I'm going boring on this one. -1, 0, 1, 2, 3. What is -3 to the third power? -3 times -3 times -3. -27. When you cube things that are negative, they're still going to be negative. So -2 cubed would be -8. -1 cubed would be -1. 0 is obviously 0. And then when I cube 1, that's just 1. Cube 2 is 8, and cube 3 is 27. Okay, so looking at what we need to do to our points, the only thing inside the parentheses is the x minus 3. And remember, these affect the x's inversely, which means what are we going to do to our x's? Add 3, yes. If we struggled with that, remember, I always like to write myself a little equation that just says x minus 3 equals my numbers, and then solve it. And that would help me see, oh, I just need to take those numbers and add 3. So all of those x's, we're going to add 3. Okay, and then the y's are straightforward. What you see is what you do. So what are we going to do to our y's? Multiply them by -1/2 and add 2. Using order of operations. So your multiply comes first. Multiply. Matthew, you got that one done already? And then, oh, I wrote 37 on this one. It should be 27. Sorry about that, guys. Fixed it. So I got multiply by -1/2, then add 2. X's definitely look a lot easier than the Y's. Let's see, -3 plus 3, 0. So we'll have 0, 1, 2, 3, 4, 5, 6. Makes that easy. Let's do the math on the y's together. A -1/2 times -27. Well, that would turn to a positive. And then what's half of 27? 13.5. And what's 13.5 plus 2? 15.5. Good. Okay, -1/2 and -8. Again, that would turn into a positive. Positive what number? Positive 4. Plus 2 would make a 6. Okay, -1/2 and -1, that would turn into a positive 1/2, 0.5. And then if I add 2, what do I get? 2.5. Okay, that would be -1/2 is 0, that's 0. And then plus 2 is 2. -1/2 and -1, well, that's -0.5. What's -0.5 plus 2? -0.5 plus 2, what? 1.5. Good job, Reba, 1.5. Okay, -1/2 of 8 would be -4. And what's -4 plus 2? -2. Look at us. What doesn't kill us makes us stronger. Our brains are so strong right now. -1/2 27 is -13.5. Plus 2 would be -11.5. 2 of these are not going to fit on the graph, and that's okay. You don't have to plot all of them, but we'll do the ones that will fit on the graph. So I'm going to skip the first one because it doesn't quite fit on the graph, but I can do 1/6. And I can do 2.5, 3, 2, 4, 1.5, and then I can fit 5, -2. And then just to kind of remind you what this looks like, looking what the parent function looks like, it kind of has like a little snake shape to it. Ours is facing the other direction because we did have a reflection, so our snake's going to be kind of going the other way. We'll just connect the dots, snake it through. Ta-da. Beautiful. Making great time. All right, let's look at our practice AP questions. Actually, I'm going to make sure everybody's got their graph. Good, good. All right, let's read through it. First, for function f, if f of 0 is -7, which of the following correctly describes the graph of y equals f of -x? Now, I'm going to highlight that in a specific color because it has a number inside the parentheses. And I know that things inside the parentheses, are they going to affect the x's or the y's? They're going to affect the x's, yes. What they gave you on the left that I highlighted in yellow, that's a point. They're just giving it to you in hidden special notation. So they're not giving you 8 points on a graph, they're just giving you 1 point on a graph. So your job is to take that 1 point, apply this transformation, and then see which one that matches. I'm going to see if y'all can get it in your groups. I'm going to give you about 1.5 minutes to talk about it. Taking that 1 point, applying this transformation, and then finding the correct answer. Again, the highlight in yellow is technically just an ordered pair. They just gave it to you in a real funky way. So step 1, gang, is to maybe write down what that would be as an ordered pair. Like make a tiny little table. Apply the transformation, and then find new point. Good job, Lenny. You guys. Here, a lot of good conversation. Join the group, talk. What should happen? Write it down as a point. Write it down as a point.
So if x intercept is less than y intercept 0.
All right, let's grab our whiteboard. Let's put our final answer on a whiteboard. Final answer on a whiteboard. That should have been sufficient time for you to take 1 point and apply 1 transformation and find an answer. All right, show me a letter. That is a highlighter, not a whiteboard marker. But I mean, yes, oh my god, good job, gang. It was D. It is the exact same point when you apply the transformation. F of 0 equals -7 is the ordered pair. 0, -7. This transformation, remember, whatever's inside the parentheses is going to work opposite, inversely from what you see. So if this is multiplied by a negative, what are we going to do to our x's? No. You're going to, let me show you. You're going to take what's inside the parentheses, set it equal to a number sign. How do you cancel a negative off of this? Multiply by a negative or divide by a -1. So the inverse of multiplying by a negative is to divide by a negative. So if I took this x value and divided by a -1, what's going to happen? It's going to still 0. It's going to equal the same point. So it stays 0 and -7, which makes it answer D. I heard a lot of good explanations as to why this happens, because this point is literally on the y-axis. So, and the transformation is a reflection over the y-axis. So if you take a point on the y-axis and reflect it over the y-axis, it's going to be in the same place. That's why. Okay, bottom question, similar. They give us just a random function. This is not any type of special graph. This is just a random graph. They're saying this is f. Okay, so does f have some points on it that you could probably find? Yeah, it has some points you could probably find. Which of the following represents the graph of f of 2x? And since that 2 is inside the parentheses, I'm going to highlight it in my x color because I know that things inside the parentheses affects x values inversely from what you see. Inversely from what you see. So we need to find some points on the graph, do the inverse of multiplying by 2 to those x values, and then find our new graph. Again, I'll give you about a minute and a half, see if we can find it, and then we'll come back together. So you're finding some points on that graph. You're using this transformation, f of 2x. Remember, anything inside the parentheses affects the x's. And then you're looking for your new graph. So I would start by just maybe finding some points on that wonky shaped graph. So Matt, you're going to need to write down some points on that little wonky shaped graph. Good. I see you find some points on the wonky shaped graph. I don't, he's just guessing. He's guessing. You don't really work, man. Nice game. Good job. Good job. Very good job. Write down the x values from. Good job. Good job. Good. I think I was looking. Good. And then what are you going to do your x values on them? All right, 3 seconds. I'm going to have us just do a quick response. Show of fingers. Show of fingers. 1 finger if you thought it was A. 2 if you thought it was B. 3 if you thought it was C. And 4 if you thought it was D. A, B, C, or D fingers. Okay, A, B, C, or D fingers. It was B, 2 fingers. Let's look at why. So I took my original points that I found on this wonky shaped line, and this transformation was inside the parentheses, so that's going to affect x inversely, which means what are we going to need to do to our x's? Divide them by 2. Very good. X equals your numbers divided by 2. So all of my x's divide by 2. And then we'll be able to see our new points. That would become negative 1, 2. This would be negative a half 1, positive a half 1, and then 2 divided by 2 would be 1, 2. And that perfectly matches graph B, negative 1, 2. It's hard to see, but yeah, they're in there. Negative 1, 2, negative a half 1, positive half 1, and positive 1, 2.